Welcome to Study Loop.
Okay, so for this one, we want to plot the old thin disk's luminosity density as a function of z for r equals 8 kiloparsecs. And we're given a formula LRZ equals L0 e to the minus r divided by hr hyperbolic secant squared of z over z0. Okay. Well, just doing a rough sketch of this, let's move this to the left and to the right. If this is z right here, kiloparsec, and let's say that going up is L, and let's say I have a graph going from 2 to -2 on this axis, and this guy goes up to increments of, I don't know, let's say 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, and 1.6. When you graph this and plug it in your calculator, you get something that looks like a bell curve. So, trails off like right here, and it goes up, and it's very symmetric. Something like that. So it looks like a bell curve. Okay. So that one you just have to plug in your calculator, or in a graphing calculator, or other graphing application. Okay, or software. Now B, let's prove that for z is really, really big, so z is a lot bigger than z0, let's prove this formula. Okay. Well, I know that hyperbolic secant of z over z0 equals 2 over e to the z over z0 plus e to the minus z over z0. So if I square all of this, I get secant, or hyperbolic secant, squared of z over z0. That equals 4 over e to the 2z over z0 plus e to the minus 2z over z0 plus 2. Okay, now in the case where z is much, much greater than z0, we can use an approximation to say that hyperbolic secant squared of z over z0 is approximately equal to 4e to the -2z over z0. Okay, and now all that we have to do is plug in into our luminosity density formula, which says L of RZ equals L0 e to the minus r over hr hyperbolic secant squared of z over z0. So here we go, and when we do that, we get the result. LRZ is approximately equal to 4 L0 e to the negative r over hr e to -2z over z0.